This is 1.3 out of your book 6th grade math, powers and exponents, page 15. Key vocabulary for this part of the chapter is factor, base, and exponent. So let me get my pin going here. And let's go up here, and for factor, we got our little thing here, factor. The best way to do factor is to give you an example like 3 times 5 equals 15. 3 and 5 are factors. These are the factors. So I could say it this way. 3 is a factor of 15. It means 3 can go into 15. And 5 is a factor of 15. It means 5 can go evenly into 15. Or I can say 15 has 5 as a factor and 3 as a factor. A power and a base and an exponent, I'm going to do that with the one example, 3 to the 5th. If you look in the middle of page 15, there's a key concept box that says the base of a power is the repeated factor and the exponent is the number of times the factor is repeated. So exactly what do they mean? This number right here, the 3, is the base. That's the big number. The 5 is the exponent. This whole thing can be called a power. So we have 3 to the 5th. So let's go back to that. It says the base of a power is the repeated factor. So that means the base is going to be repeated however many times the exponent tells us to. So this number right here, the 3, is being repeated 5 times. 3 times 3 times 3 times 3 times 3. And then if they wanted the answer, we would multiply that out. So we have 5 3s. So let's take a look at some powers and exponents here. Our first example deals with the Virgo spiral galaxy. At the top of the page, there's a little thing written about, it says astronomy, right? There's a picture of it up there, kind of a cool picture on the top of page 15. A light year is the distance light travels in 1 year. Astronomers estimate that the distance across the Virgo spiral galaxy is about 100,000 light years. You can write 100,000 as a product. So write this distance as a power. So you'll notice that 100,000 can be written 10 times 10 times 10 times 10 times 10. I lost track. 10 times 10 times 10 times 10 times 10. Oof, it's hard to keep track. I'd use my fingers to count right there. The tens are factors. The 100,000 was the product. Notice 100,000 has 5 zeros on it. Then there's 5 tens to make up those 5 zeros. So what we can do is we can take this and we can write it as a power. 10 to the 5th. The 10 is the repeated factor, and it was repeated 5 times. So that's where our power comes in. So let's take a look at, there's the 5 factors. It tells us answers 10 to the 5th. So let's look at some guided practice that you're writing along with me right here. Here we have 8 times 8 times 8. 8 is the repeated factor, so 8 is the base. So we have 8, and how many times is it repeated? 3 times. 8 to the 3rd. And do they have the answer? Here we have 6. 6 to the 4th. It's 6 times 6 times 6. So the repeated factor is 6, and it's repeated 4 times. So we have 6 to the 4th. That works out good. 20 times 20. 20 is the repeated factor. That would be 20 squared. And 11 is the repeated factor. So how many 11s are there? 1, 2, 3, 4, 5 of them. So it's 11 to the 5th. This pen has ideas of its own sometimes. And we have 7. It's 7 is the repeated factor 1, 2, 3, 4, 5 times. 7 to the 5th. Well, that works out good. And let's see here. 15, I think this is the last one. 15 is the repeated factor. 15 to the 3rd. So that works out great. 15 to the 3rd. So if you look at the top of page 16, it talks about reading powers. It says when powers have an exponent of 2, the base is squared. When powers have an exponent of 3, the base is cubed. So I'm going to just write that. Let's say, like the example, it's 3 to the second, that would be read 3 squared. So whenever you see squared, it means to put a little 2 for the exponent. And then let's say we have 4 to the third, that can also be 4 cubed. So whenever you see the word cubed, that's your key that there's going to be an exponent that's going to have a 3 on it. And then all of them bigger than that, like in the book it says 2 to the 5th, there isn't a little, it would just be 2 to the 5th. Alright, so example number 2 says find the value of 5 cubed. Well, we know now what cubed means from down here. Okay, so 5 cubed means 5 cubed, 5 to the third. And then now it's asking us to find the value, so that means we got to figure out its answer. So what does 5 to the third or 5 cubed mean? The 5 is repeated 3 times. Whoops, 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 whoops. 5 times 5 times 5. 5 times 5 is 25. 25 times 5, and I always think 5 quarters because I'm pretty good with money. $1.25, so 125. Well, let's see how they did it. 5 to the third, 5 times 5 times 5, and then we get 125. So that worked out good. Find the value of 2 to the 6th power. Well, let's see here. 2 to the 6th power would be like this. So it'd be 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. I need one more. And value means the answer, so I'm going 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power then would be 64. See, they wrote them. There's all those 2's, and they got 64. Works out good. Okay, let's look at powers in real world problems. Telephone calls. You need to contact members of your softball league. You call 4 members in the morning. Those 4 people each call 4 more people in the afternoon. That evening, those additional people call 4 others. How many people are called that evening? So everybody's calling 4 people, you'll notice. So we first start off by calling 4 people. Okay, and then those 4 people are going to call 4 more, and those 4 people are going to call 4 more. So basically what's happening is we are multiplying 4 times 4 times 4. In other words, 4 to the third. Okay, which would be 4 times 4 is 16. 16 times 4, which sometimes I just go off to the side and do a quick little calculation. 4 times 2 is 6. So you would be calling 64 people right there. So let's take a look at the guided practice as we go through here. Oh, here's their solution. You call 4 people, they each call 4 people, they each call 4 people. Write the power as a product, then find the value. Okay, so the power as a product means I need to write it out. So 11 squared means 11 times 11. Sorry, the pin's not working again. And then find the value. 11 times 11. If you can't do it, you just do the 1 times 1. 1 times 1 is 1. At a placeholder, 1, 1, 121. Works out good, 121. 8, 5 to the 4th means 5 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5. 725. So, just a lot of multiplying, as long as you get the right numbers. Got it right. Still doing the same. 3 to the 6th power. So that means we go 3 to the 6th. 3 times 3 times 3 times 3 times, oops, times 3 times 3. 1, 2, 3, 4, 5, 6. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. 243 times 3, 9, 12, carry the 1, 7, 29, is that right? I don't know if I did that right. Let's see if I did. I'm trying to do that multiplying really fast. Oh, look at that, 729. See, if you know your facts, it makes it a lot easier. 6 squared, well that's going to be smaller, squared means a 2. 6 times 6, which is 36. Yay! There's the answer on there. Okay, the guided practice. What if, suppose each person in example 3, including you, calls 6 people instead of 4 people. How many people are called that evening? So if you remember, you call 6 people, then there's 6, they call 6, and then they call 6. That would be 6 to the 3rd instead of 4 to the 3rd. 6 times 6 is 36. Right here doing these two. And 36 times 6, 216 people. So, a lot of people called that way. $216 people are called that evening, making sure we label it because it is a story problem. So that's it. It looks like you're ready to head on to do the assignment for 1.3. If you have any questions, please let me know. See you next time.